different types of chemical reactions. How do we predict which products come from which reactants and know which type of reaction we're looking at? Not by the end of this, most likely, but eventually you're going to need to be experts on identifying these 5 types of reactions. There's tricks for each, so if you pay attention and practice, you shall be good by the time you need to know it on your quiz. Go ahead and pause and write down those 5 types of reactions: synthesis, decomposition, single displacement or replacement, double displacement or replacement, and combustion. I'd recommend watching this. Go Google search the 5 different types of chemical reactions, and then unpause this and continue. All right, so the first type of reaction is called a synthesis. Hopefully you know in English the definition for synthesis or synthesize means to make something. And in a synthesis reaction, 2 or more reactants combine to form a new compound. So an example would be carbon plus oxygen. 2 reactants make carbon dioxide, 1 product. So when you start with 2 things and you make 1 thing, you're going to be looking at a synthesis reaction. So the generic equation is A plus B makes AB. In other words, they combined. So in our example up here, this molecule would be A, this would be B, and they're stuck together, so that's AB. Synthesis, start with 2 things, you make 1. That's the key to identifying synthesis reactions. One thing you can learn, it's not going to be super important, but it's worth knowing, is you can crisscross the charges to balance. How do we know, what are we talking about? In a synthesis reaction, we can do this by magnesium and nitrogen. If we look them up in the periodic table, magnesium has a +2 charge, nitrogen has a -3 charge. So what's that mean? Put that 3 on magnesium, put that 2 on nitrogen, and that's what's going to form. So when we predict in a synthesis reaction, and we actually have the accurate number of each, so it would be really balanced if we needed it to be, that's how it's done. You won't have to go that in depth, but just be aware. Here's a real example at the bottom of a synthesis reaction. It says we start with 2 potassiums and a chlorine molecule, 2 chlorines stuck together. That's 2 reactants, and we make 1 thing, 1 product, 2 of these potassium chlorides. Start with 2 things, we make 1. It's going to be a synthesis reaction. If you're paying good attention, you notice next to those we saw little S's, AQs, and G's. That tells you the state of matter that the substance is in your reaction. So S stands for solid, G for gas, AQ means aqueous, aqua, water, which means like it's in liquid. Who cares, right? Why do we need to put that all of a sudden? Well, because sometimes the phase can change. You might start with 2 solids and make a liquid. You might start with solid and gas and make a liquid, whatever. That's why they mention them often in reactions. Second kind of reaction is decomposition. If you know your conservation, decomposition means to break something down, and that's what happens here. We start with 1 reactant, and we break it down into 2 or more products. So we start with NaCl, which is salt. That's 1 reactant. We break it apart to 2 different products, chlorine and sodium, and that makes it decomposition. So the general formula, AB, 1 thing, breaks apart into each thing separately. So this would be our AB, 1 unit stuck together, and they separate out into the A by itself and the B. So synthesis, we start with 2 things and make 1. Decomposition is the opposite. We start with 1 and break it down into 2. A real example down here, we start with mercury 2 oxide. Remember, mercury 2 because it's transition metal. And we split it up into those 2 things. We split it up into mercury separate from oxygen. So start with 1, end with 2, makes it decomposition. Single displacement or replacement, if it says placement, you're fine. Displacement or replacement will be the same. 1 element replaces another in a compound. So we look here, zinc plus copper chloride. There's our copper chloride, there's our zinc, and look what happened. Zinc replaced copper. So instead of Cu, ClCl, we have zinc with the Cls, and that puts copper by itself. So 1 element replaced another, well, single, and replacement. You might think of it as replacement instead of displacement. So single replacement reactions, one molecule replaces another in a compound. What's that generic formula look like? AB plus C goes to AC plus B. In other words, this would be our AB molecule, because it has two things stuck together, two different elements. This is our C molecule. Notice the C kicks out the B. So zinc kicks out this, which makes this now AC, and what we call B, copper, gets moved to its side. Single displacement. One element replaces another. We're not going to worry about redox other than understanding sometimes you change charges. Over here, zinc was neutral, now it's a +2. Copper then was a +2 and now 0, so they kind of traded not just places but charges. And we call that a redox reaction. The one thing you might need to know in that is what is considered oxidized, what's considered reduced, and really it all boils down to this statement. Leo the lion goes grr. L, lose. E, electrons, means O, it's oxidized. So whatever loses electrons would be oxidized. Grr, G-E-R. G, gain. E, electrons, that means it's reduced. Metals tend to lose electrons, which means they're oxidized. Nonmetals gain electrons, which means they are reduced. Here's an example of a real single replacement reaction. Start with lithium and water. All right, so lithium is going to kick out a hydrogen to form lithium hydroxide and separate that hydrogen out. One element replaced another. Lithium replaced hydrogen, so it's a single replacement reaction. So what you're going to try to do here is predict what forms. I already did this one, so I'll show it to you. Here's how it works. Zinc, since it's a single replacement, replaces hydrogen. That's where we got this. But notice this equation is not balanced. So if you want to, press pause and try to balance this. And remember to balance, separate, write each thing, each element on each side. They're always the same, so I could put whatever's on the left side on the right, and then I will count them up. 1 zinc, 1 H, 1 Cl. 1 zinc over here, 2 H's, 2 Cl's. So I need my H's to equal 2. I multiply this by 2. That gives me 2H and 2Cl. So that would be the balanced equation. Still going to practice those as we go forward. All right, you try this one. Pause and tell me what forms and see if you can balance it as well. So F will replace that. One thing replaces another in the single replacement. Come on. NaFCl2. Is this balanced? Well, Na, there's one of them. Cl1F2. Over here, Na1, Cl2, F1. Oh boy. Cl's are not balanced. So I need this to be 2. That's going to change my NAs and Cl's to 2. Now my Na over here is 1, and I need it to be 2. So that changes Na and F to 2. And that means everything's balanced at 2. So that's our real equation. All right, single replacement. Now we go to double displacement or replacement. Now 2 elements are going to replace each other. Example, MgO, magnesium oxide, plus CaS, calcium sulfide. Well, there's what we start with. We're just going to switch everything around. Notice, magnesium moved over here, replaced the calcium. Calcium moved over here, replaced the magnesium. 2 things replaced each other, and that's why it's called double displacement. Now, when we're telling the difference between single and double displacement, in double, we're going to have two compounds. So two different elements combined. Two elements combined here and two here. If you remember, on our, let's go back, our single displacement, we have one compound and one element. So single only will have one element by itself, and double will just have two compounds in it. The formula for that is AB plus CD, so we call this AB, CD, because calcium, which was D, goes to oxygen. That's going to be our AD, and now our C's and B's moved. So the key is, this is a weird one to look at. Just know, start with two compounds and two things switch places. Two means double. How do you know when you are predicting what goes together? This is really important. Remember, in algebra, you FOIL, first, outer, inner, last. So the first and outer ions go together. So Ag will go with Cl because they're first and outer. And then you always start with the first, whatever element is listed first in its compound. So the inner would be NaNO3. First and last would be KNO3. Inner would be BaSO4. That's how we figure out what they're making over here. Oops. So when we do that, we're not saying balance here. I'll do the first one. We said first and last, so that would be HNO3. I'm not worrying about balancing. Inner AgCl. Press pause and try the other two, and then I'll give you the answers. Oops. Here, hopefully you said CaPO4 plus NaCl2. And down here it should be FaOH and NaCl would have been your answers, but they'll be in the note guide. Last type of reaction is a combustion reaction. So, this is a weird one. There's not a pattern. It's not like A plus B, blah, 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 blah. But the way we're going to know we have a combustion reaction is oxygen will always be a reactant by itself, O or O2, and we're always going to make carbon dioxide and water. The other reactant is going to be a hydrocarbon, meaning it's only made of hydrogens and carbons. But really, if you see an oxygen in a problem on the left side, the reactant side, you are going to pick combustion. Hydrocarbon, when they say that, they just mean it only has C's and H's, and we will always have oxygen on this side. And these will always be our products, carbon dioxide and water. They're always made in combustion reactions. A lot to put here, so go ahead and pause and put that into your notes. If you want to Google search Mr. Parr chemical reaction song, I'm going to skip it here. Add some more notes. Press pause while you put this in. So this is a nice summary page. Gives some examples. Goes over each type. They say addition. We called it synthesis. Same difference. Remember, in synthesis, two separate things combine to form one. The opposite is decomposition. We break down one thing into more than one thing. Single displacement, you always have something by itself that replaces something that was in a compound. Doubles displacement, you have two compounds, two things combined that both switch places. And then combustion, got to have O2 on the left side, CO2 and H2O on the right. So, I'm not going to make you predict the products. That's there for you. Right now, I want you to be able to identify, because you're going to have to identify a lot on the quiz eventually, what type of reaction do we have? So maybe press pause and in your head say 1's a combustion, 2's synthesis, whatever you think, and then I'll go over it. Press pause first. All right, let's go through these. How do I know? I have two separate compounds. BA moves over here. H moves over here, so two things move. I have two compounds. That's going to be double displacement, double replacement, displacement, whatever you want. Number 2, oxygen's on the left, carbon dioxide, water, that makes it combustion. Number 3, I have one element by itself and a compound. The element replaces, but really if I have one element and a compound, it's going to be single replacement. Here, two elements combine to make one thing. That's synthesis. They're making something. Two things combine to make one. This is the opposite. I have one thing that breaks up into two, and that would be decomposition. You'll get better. We'll practice a ton of these, so don't feel bad if you missed a lot or even all of those. Go ahead and copy the correct answers into your notes, and then you are done.